Alright guys, hey, welcome back to Foaming at the Mouth Friday Live, and we're here with Matterhackers. We've got Dave Gaylord, and we've got Alec Richter here, and this is kind of cool because we've known each other for a while now. Us kind of getting involved with 3D printing and it's from an educational standpoint, and using it as a teaching tool to show how all these cool things are made. And you guys have been around for a while now. You've moved a couple times since I first saw you and met you and everything else. So tell us what's going on.
Been around since 2012, so we've turned into one of the largest 3D printing desktop retailers in the U.S. Geographically, we're located right down the street from you, so that's pretty convenient. We sell 50, 60 different kinds of desktop 3D printers, so mostly the FDM stuff. That's the biggest thing that's kind of taking off, especially in industry, hobbyists, and education. Kind of a lot of FDMs being used right now. We sell filaments. We make a software called Mattercontrol, which is super useful as a controller slicing engine that we write.
Yeah, that's what I started off on, was Mattercontrol, Matter Slice and all that.
Yeah, with the Airwolf that you had, which is an awesome machine back in the day. So anything 3D printing, Matterhackers is the place to go.
Yeah, and then now basically we're in Orange County. They're literally just a couple miles down the road, more or less, as the crow flies. And specifically, you guys are in Lake Forest.
Yep.
Have your own little retail store. In fact, on Friday when I went in there, you guys had a pretty cool guest come in, huh?
Yeah, Grant Imahara from the Mythbusters guy came in.
I was jealous.
Purchasing an Ultimaker 3, so he's sounds like he's going to get to work on some cool projects.
Yeah.
Using 3D printing.
I was there like an hour and a half or 2 hours right after that. I was like, could have geeked out with you.
Yeah, we were kind of like in a freaking out. It was like, hey, Grant's up front.
Yeah.
I have something to take care of up front. I should go be there.
Yeah. I need to go check and make sure the trash cans need emptying or something.
Within our office, he was an A-list celebrity.
Right?
So
Hey,
kind of fun.
In this world, no, it's cool because it's I think growing up and being someone who likes to make stuff, and I just consider myself kind of a geek. It's not something a badge I wear proudly, but I think people like that, they're doing stuff like this cool.
Yeah.
And I mean, realistically, like this is. From a job training, making yourself more marketable as an employee. I mean, if you can learn how to do this stuff, it's very important. I mean, it's also fun.
Yeah.
You are always learning and you're always trouble solving, and so it's like you grow as a person. I think when you try to get into stuff like this, because this is challenging. I mean, it's not easy. It's fun, but it's worth.
Yeah.
It's worth doing, but it does take time to do it.
Yeah, we see it as the future. I mean, right now there are hobbyists, some engineers that are doing prototypes on their desk, and even education starting to really engage in the 3D printing. In 10 years, I certainly think there will be, maybe not a 3D printer in every home, but a 3D printer on every professional's desk. And certainly kids will be using it. Once those kids that used it in elementary school today, once they graduate in 15 years to become professionals, their competency in 3D printing and their ability to make, their ability to digitally create and physically have an object will be super powerful. I mean, as an engineer, I would have lost my mind if I had this
right, I know. Wouldn't it be great to be like a 10-year-old kid right now and like be able to play with this stuff?
Yeah.
And it's funny because it's like, I've jumped into it. I have a friend who he builds a printer and I use his printer, and then we've had some printers here at work that I've been lucky enough to get a lot of experience with to use for showing how our products are relevant to that industry.
Yeah.
Because 3D printing is not new. A lot of people think it was just magically invented 10 years ago. It's been around for like 30 years in different forms, but it was not accessible because it was very expensive for the equipment, very specialized. I mean, you needed to know things like SolidWorks and whatnot, and that you basically had to go to school for that. Whereas now, everything's open source. I mean, I've taught myself a lot of 3D modeling just tinkering around on Tinkercad, and then you can graduate up to things like Fusion 360 or 123D Design. And it's really easy. And when I used to go to these shows for BJB, to these big 3D printing shows, with our company, I always thought, the breakthrough is really going to become when you can make easy to use programs, so that your average Joe. I was a graphic designer, but I never did 3D design, so it was like that was still a leap for me, and I adapted well. But it's still a long learning curve. So if you can start off with something easy like a Tinkercad, anybody can
Tinkercad's the
use.
place to start. I mean,
Oh,
we
yeah.
always recommend that because it really is the Lego version of digital design. You can
Yeah.
take a square or a brick and move it here, and then a triangle, and eventually you can create a really organic house if you spend enough time and move enough of those blocks around.
Yeah.
Super easy to add things, subtract things. Whether you're an adult or a kid, it's kind of perceived as made for kids, but anybody getting introduced into 3D design space that doesn't have graphics or an engineering background, it's the best place to start, just
Yeah.
in terms of ease of use. So
Well, and not only mentioning that, I mean, you can download all sorts of files from like Thingiverse, and because I go on there and I go, well, I kind of like this, but I need a little modification, and you just drag it in. Hey, I need to punch a hole there, or add a little section here, and you can do it very crudely.
Yeah.
But what's cool is then you can just go and 3D print it,
Yep.
and the 3D printer doesn't really care if
Yeah.
it was. If you tried to do stuff like that in like SolidWorks, it
Yeah.
cause all sorts of errors.
Yeah.
So it's actually very very easy. But yeah, we're excited to kind of have you on today. We're going to talk about some different kind of things, obviously from your angle of it, and then I know there's some crossover. Of,
yeah,
you know,
we've
mold making,
got
casting
questions
stuff.
about the mold making process. We've done some of it, but I'm sure you can recommend like more specific
Yeah.
materials that you guys have that
Yeah.
are best suited for mold making, casting, making flexible parts more flexible, rigid parts stronger, even that are 3D printed.
Yeah. So cool. So so obviously you guys brought a bunch of sample parts here today to kind of
Yep.
show, and I don't know, this is kind of a lot of your fun stuff.
Oh,
huh?
yeah.
You want to talk about it?
So I printed probably most of the things on this table. This is just a disc from Iron Man's hip. It's like what he twists and a bunch of flares come out. One of our coworkers, Tyler, printed this. He's working on a full suit.
Nice.
Head to toe, full suit.
Head to toe. It's
been 2 Halloweens now that we've projected it to be finished.
I'm pushing it.
That
Now that
happens.
I'm here, I'm pushing him.
All right.
This
Because
is-
everybody needs an Iron Man suit.
Absolutely.
Oh, absolutely, of
Sorry.
course.
Custom fitted.
Both of these guns are from Fallout. This one's made by Lilykill. He's on Instagram, Thingiverse, My Mini Factory. He's the only artist's name that I remember, just because I've printed almost everything that he's designed. I'm that in love with Fallout.
Cool.
Got a couple 3D printed Joels, 3D printing nerd, a Nick Offerman bust. This is Tracer's gun from Overwatch. We've got 2 at the office. This is the one that's static. The one at the office has a trigger that pulls and has lights come on. This is the infamous Blade Runner gun, which has working triggers.
Wow.
A little, like a bolt can come back, which is very interesting to have for a pistol. Let's see, oop, there you go. You can get the revolver to open up. And then we've also got this, which is printed in an Protopasta iron PLA. It's magnetic, and it's magnetic because it has iron in the PLA. And this isn't a patina; it's actual rust because of the iron in it. So
Oh wow. Can I see that?
yeah,
That's cool.
so that just sat in a vinegar, hydrogen peroxide, and water bath for a weekend.
Yeah.
After spending the previous weekend in a tumbler.
Yeah.
So it's got some weight to it. And,
Yeah, it's definitely dense, and it's
got
got
some good rust.
There you go.
Yeah, some
Yeah.
of the cool parts are like how you can post-process like regular 3D printed parts, and then even from how you might mold them and cast them. That's how you get to the place where you get a super smooth surface.
Yeah.
There's some elbow grease involved sometimes, but
Like this one was really easy to post-process because, so Tyler also printed this. He printed this in ABS.
Okay.
So there's no paint. This is the white ABS and the acetone smooth it.
Acetone vapor polish. Yeah.
That's
Okay.
exactly what it did. So that has a really nice finish on it, and there was no like sanding or anything like that. And these are some grenades for Soldier 76, which is this guy. We're going to be at WonderCon, so needs to have the full setup, and it's got a threaded canister
Oh, nice.
to go on top.
So those would be like little hip accessories or
These
something.
go on the hip.
Yeah.
These go on the shoulder.
Nice.
Not sure why they're different sizes, but that's accurate to the game, and I'm following that.
Cool.
This one screws as well. Most of these are printed in PLA. We've got a lot of selection in colors, so sure, print the handle on that, and this, I don't know, make it purple.
Yeah, that's cool. Yeah, you know, and this is what's neat. Obviously, and after you're in this for a while, I mean, you end up with all sorts of different colors and whatnot. And you know, you've got the translucent. I've been falling in love with like PETG.
Oh, yeah.
Just as a general material, high impact, stable.
Dave likes PETG.
Yeah, I mean, it's kind of like it's kind of like using PLA from a user friendliness. It doesn't work quite as bad, but it's not quite as brittle as PLA.
Exactly.
But you know, everything's a kind of a trade off. I mean,
Better heat resistance than PLA.
yeah, So yeah, it's actually really nice, and yeah, you can get away with some of these like translucent, cool colors. Yeah, I like that stuff a lot. I've done a lot of little parts for like FPV, like racing drone type things,
Yeah.
Okay,
and like
cool,
indoor stuff,
cool.
and you're always hitting and bouncing off stuff. So
Yeah.
you need it tough. Yeah.
Yeah, so most of these are PLA, which is the basic material, right? That's easy to print. Although, if you were maybe to leave it in like in your car on a very hot day, you could warp it a little bit.
Yeah.
It's got a very low thermal property, so it's really easy to print. Moving up from there, you can kind of go to ABS, which we kind of talked about. ABS is much stronger, but actually it's a little bit more difficult to print because you can get some layer separations
Oh, yeah.
happening. Post-processing, it's much easier though. So sanding it
Absolutely.
and polishing it gets it a little bit easier.
What takes a couple minutes
Yeah.
sanding it with this, I
Yeah.
can do in a couple seconds with ABS because it sands that much easier.
Gotcha.
Or I could vapor smooth it, or use acetone to weld two parts together, whereas with PLA, I
Yeah.
gotta use super glue.
Yeah. Yeah.
And then PETG is kind of maybe the next material you graduate to, and it's this marriage in between. I really love it. I think PETG will actually take over ABS in terms of its popularity at some point in time. Moving on from there, you can even go to nylons, which are super useful. Like things we use all day long are nylon. Like every screw gun, like cordless screw that you have has like a nylon case because it's really strong. You can make meshing gears with that
Yeah.
stuff because there's like a slight lubricity to
Yeah.
nylon feels. We just came out with colored nylons, so that was
Oh,
one
really?
of the
Oh,
first
cool.
in the industry to have like colored nylons, which is cool. And then we even have crazier stuff like Nylon X, which is carbon fiber infused
Yeah.
nylon. So then you
Wow.
get the structural integrity of nylon and the stiffness of the carbon fiber in there as well. So the platform of being able to print things, really, if you think about, oh, what do I need this for? How am I going to post-process it? What am I going to do with it?
Yeah.
You can go through that material selection. Our website has all the details on
Yeah,
what those
yeah.
materials are, what their printing properties are and stuff.
Yeah, that's kind of the cool thing is like when I'm on your guys' website and I'm looking at materials, and then obviously it's nice. It's kind of like looking at Amazon. You see people's
Yeah.
questions, you see the answers, you see the feedback, and
Yeah.
so on certain materials, I mean, it's as good as people will, ask the question of what temperatures do I print
Yeah.
at, what this and that, and then you get the answers, and it's kind of that community-based
Yeah.
feedback, and everybody learns quicker, and everybody learns better, and the right way to do it from the get-go. So,
Absolutely.
yeah, I mean, and of course, there's other things like, when you graduate up to those materials, you got to learn how to make it stick better to the bed,
Everything's
heated
got
beds.
its own little trick, yeah.
I'm a big fan of like the wolf bite. You guys,
Yeah.
I know you guys sell that. That stuff's really
Stuff
neat.
works, man.
I know there's some new type of bed things, but that's always been fairly consistent.
Yep.
For me, at least on
Yep.
glass, based on the printers I have.
Yeah, it's another one that's made locally right here. So
Yeah,
it's
yeah,
kinda cool.
Airwolf guys and stuff,
Yeah.
and in fact, actually, the guy who helped sort of invent sort of the technology that he's a really smart professor over at Cerritos College.
Oh, cool.
Locally,
Nice.
so that's kind of an interesting
cool.
guy, and he teaches.
Yeah.
He's shaping minds in
Yeah.
the future. So, but yeah, so it's really, I mean, I tell a lot of people. In fact, I'm a dad. I got a couple kids, and I have a printer at home, so of course my kids are going to get exposed to it. But it's funny because actually I've told a couple of my sort of friends and dads that I know, I'm like, go buy a 3D printer. Go just buy it, even if you buy a cheap one. Go down to Matterhackers.
Yeah.
They're local. They'll help you. And one of the dads I know, he went to actually Brandon who met at one of your open houses
Yeah.
back in the day.
Cool.
And sure enough, he had bought one of the small little printers.
Nice.
And of course, Dad found other things to do with it.
Yep.
And that's the thing about 3D printers is. Even when we wanted to bring one in house, everybody was like, "What are we going to do with it? We don't make parts. We don't." But the magic is you don't know what you're going to do with it, and so all of a sudden you just start tinkering with it, and you can just start as simply as just downloading free things you like from Thingiverse. You print some turn out terrible, some break the second you pull them off the bed, and then you learn, you get better. You go, okay, this needs more infill. But once you do it, you realize some of the magic you can do with it. Some of the boring at-home projects that I've been
Yeah.
able to do little repairs or little gadgets for. It's been fun because I just 3D print it, and of course it's fun to show it off to your friends.
Yeah.
You're like, yeah, I 3D printed that.
No big deal.
But going back to the education is like the sooner you expose kids to that. It's just like when we were kind of growing up, luckily we grew up when we were around computers, and you look at the generation gap of people, maybe a couple tiers up from us, and they struggle with computers. We didn't really have that issue because we were always around them, so we're comfortable with them.
Yeah.
In 10 or 15 years,
Yeah.
this is going to be much more normal, and it's going to be just not such it's not going to be so unique. It's going to be
like
part of
computers
manufacturing
in the
and everything.
80s
Yep.
versus what they are today. Like
Yeah.
we each have a computer in
Yeah,
our
I mean,
pockets in our
yeah,
phones. So
I mean,
it's kind of crazy to think about that.
More power than the
Yeah.
the original spaceships and whatnot. That they
And in
say.
terms of pricing, like it's not as expensive as people think to get in.
Right.
You can get printers as low as like $150, which I would kind of avoid because you end up having to get a PhD in how to fix printers in order to make those ones kind of function.
Yeah.
So Matterhackers is a great place to start because we test all of the machines that are out there and we filter them through our test and support team.
Yeah.
Because if you buy from us, we do customer support. We've tested it. We make sure that it's something that you can succeed with. And the industry really is going towards this thing that the ease of use and the out-of-the-box experience and like getting towards just pushing a button and walking away.
Yeah.
We're getting very close to that. So, $599 for like a Pulse 3D printer all the way up through $2,500 for a Lulzbot or an Ultimaker up to, the Airwolfs are, $5,000, something like that. That's about the price range. Anyone from I wouldn't spend less than $600 and kind of the upper ends, maybe 5,000. Just from I think even me, I'm like an engineer in my office, I would still think that printers are $100,000 things. But they are these desktop, very available,
amazing,
relatively inexpensive things.
Yeah, and I think, $600 is not, it's not exactly cheap, but you think about even like what we used to pay for computers and stuff. You can buy a laptop for a few $100. It does a pretty good job. But trust me, when you're getting new to this, and I'm no expert in this stuff, but you still, if you find you're having a printer where you have to do a bunch of manual setup, like back in the early days, to have some of the newer technology where you literally just print. You just hit kind of go, and as long as you set everything up, you're going to have a part that comes off, as opposed to dealing with like bed leveling issues and stuff like that. So on some of the really old stuff.
A lot of that stuff's getting ironed out. And
Yeah, exactly.
That ease of use, that out of the box experience is kind of where it's going. And if you ever have any issues, anyone with 3D printers, whether you've bought it from Matterhackers or not, we've got an amazing test and support team. It's what we're known for is our customer support. Our interest is actually not selling 3D printers, but everyone adopting 3D printers and being successful with the technology.
Yeah.
That's what grows our industry more than anything is people being successful, not getting it, being annoyed, and then throwing it in the corner to collect us. Which, in 2012, when there was a lot of some of the older machines coming through, that's what was happening, and we're seeing that kind of the pickup start again.
Yeah, it was kind of a war of attrition in the early days, whereas now it is people are kind of getting the advantage of what happened a few years. And it's amazing. We're talking about 2012 like it was so long ago, but in terms of technology, it is a long time ago. Yeah. Well, cool. So, so we've got, I'll get to one of my other things I'm going to show you because you guys kind of helped me out a little bit on that. It's kind of a unique thing. But so one of the things that obviously ties BJB's industry to 3D printing is sort of how, for years, it's how prototyping was done. And slowly, printers are becoming a little more capable where you're printing pretty usable parts right off of the thing. Some technologies are slightly better than others, and some things are more practical to maybe just print them all. And then there's some parts where you're like, hey, like talking about some of the elastomeric rubber parts and stuff. If you have a printer that only prints in PLA, you're not out of luck. You could just print that, use it as an example, a master or a pattern, what we call. Take a quick silicone mold out of there, and then just pick whatever you want to cast in there. And then next thing you know, in a couple weeks, you've got easily dozens or a couple hundred parts.
Exactly.
If you had to 3D print all of those, post-process them, this and that, at a certain point, it becomes worth it to take an extra day or two to make the mold. And I've seen in your shop, you guys have kind of played around with that and whatnot. So, and we've got people that are 3D printing directly to molds. I did a video on making kind of a cool quadcopter thing. I 3D printed a mold, cast foam, and it worked beautifully.
Check that video.
And
it's pretty awesome.
So, long story short, you are also working on some projects that are sort of kind of tying some of that in.
So this is the Soldier 76 mask from Overwatch. Originally, this was just the model straight from the game, which was very, low poly, just enough to look good on screen, but not so good when you download it and look and like, oh, that doesn't have any detail at all in it. So break out the Bondo, and the sandpaper, and turned it into this.
Gotcha.
Since then, I've modified that file to be more like this one, because this one was just the same, where it was super low poly, and Tyler uses Blender, which is a free program. He cleaned this up. I did the same thing after learning from him, so I have a version that I'm working on that's totally smooth, straight off the printer, and so I have to do very little sanding on that.
Nice.
But with this, I can't fit this I can't fit this over my head. No way. So the plan was to make a mold of this and either cast the whole thing in like a rubber, or to cut it along this line and make this part rubber and come off, or just peel open so I can pull it back and squeeze my head into it.
Well, that's actually really clever. Yeah.
Because you know, I had this is like Mark 4 of 6. Mark 1 was big enough to fit my head through, but too big to actually look right.
Oh, okay.
It looked like a bobblehead.
Yeah.
So, you know, with 3D printing, I'm able to go through different iterations and change up the size and maybe change some details. This didn't work, cut that out, add that in. So, with 3D printing, 6 different iterations took me a week to figure out that issue.
Yeah. Yeah, that's a beautiful thing, is like, you know, you can just start over, and it is time consuming. I mean, it does take time, but the nice thing about printing is you can kind of set it up, start print, walk away, come back, and but there is a lot of post processing, and so it's like, you know, our sort of our story of how this all integrates is you have to ask yourself, am I going to make more than a couple of these?
Yeah.
Then it might be good to invest some time into really doing some body work, you know, cleaning this up super nice, and then when you make a mold, they all pop out like that, and you do very minimal cleanup. We've posted some pictures. We're gonna get back on that project a little bit later, but it was kind of a side project. We did a stormtrooper helmet, one of the kind of the old school ones, and we 3D printed it, and it was something like 20 something ridiculous pieces. And fitting it all together, and if it was just if we just had to do the one, then you know, then you'd have about, I don't know, 20, 30 hours, 40 hours sunk into this thing. But we're like, hey, wouldn't this be cool to make a mold of? And then we could actually just rotocast them on our rotocast machines. And so anyway, the long story short is, you know, sometimes it's good to invest a little bit more time, finish it up. And then also, too, it's sort of like an archival piece that's safe from destruction. Like, you'll have it there, and you can make more and more parts and keep that one as like you know, keep it on the shelf safe in case something happens to the other ones you're working on. So yeah, it's kind of a cool process. And mold making is like 3D printing. It's a whole nother technique. It takes time. Start with a simple part, and then, you know, graduate up, unless you really want to you know, frustrate. If you try to dive in too deep, too fast, you know, then you might kind of get in over your head. But
I think you guys have really good videos on kind of how to get started and build the box for the stuff in. So we have some stuff to learn from that even. I think Alec's done it a couple times with some of the things that he's
I've done a couple molds. I got to refine the process.
cool.
Put it that way.
Yeah, and so you know, in our knack, kind of like you guys, it's like ultimately, you know, we don't want to just turn and burn people, you know, selling materials. It doesn't really, because, you know, ultimately we want the end user to be successful. We want you to be successful out of the gate. And we got a lot of the same questions and sort of troubleshootings and things like that, and then we slowly, obviously, turned those into videos, common questions and whatnot. So so it's very symbiotic. I mean, our industry has been around for a long time. You know, the explosion of 3D printing, the accessibility, and a lot of people are always asking, like, well, aren't you afraid that it's going to like replace you? But it really hasn't, because if you go to Kickstarter, look at how much innovation, look at how many new developments, and people are trying to do things better, differently, simpler. And now you've got the accessibility of doing your own prototypes. And I mean, it's invaluable. We've had a lot of people who were on Kickstarter that said, I 3D printed all my prototypes, now I've got to make 1,000 of them. And it's like, okay, well, you're not going to want to 3D print all those, because you know, your printer envelope is this big. How about if we make, you know, a few molds, and then you're knocking out, you know, a dozen or 20 in a day?
It still makes sense from that scalability for the technologies to work together. So.
And then eventually some of our customers grow up and they go off to injection molding, you know, and that's fine. And it's just all part of the process and of innovating. And but yeah, I mean, I love 3D printing. I think it's fun, and it's certainly a technology that's not going anywhere. It's only going to get better, and we just have to find, you know, the techniques to work. But what's kind of funny is, you know, and we go to a lot of these shows, we talk to, you know, young engineers and people that are coming on, and they always kind of go, well, you know, what is your process? You know, why would you do that? Why don't you just 3D print more? And, you know, you guys would be the first ones to say it as well. It's like, you know, there's a point in which then you kind of, there's a tipping point of where it's more work to try to force something that's a slower process, or you know, more labor work, and and then you can exchange it for maybe making molds and stuff like this. A lot of the costumers, we've got customers that do sell costumes in cosplay and
Yep,
whatnot.
I got a couple friends that do that.
Yeah, and it's a good investment to sort of have that 3D printed part, tweak it until it's right, and then boom, then you can make a mold and make lots of them.
One of my questions for you would be like somebody starting, they've got a 3D printer, they know what they're doing, want to make a mold, they can check out your videos and stuff, but what are the materials that they need to start with? Like, I think I go through, your website and it's just like, do I need platinum? Do I need
Right.
rich shore hardness? Do I need,
Yeah.
like, what's the most common mold making material that you can just get an AB? And then what's the most common casting material that someone
Okay.
can succeed with? Just clear and easy, and why?
Yeah. So silicone molding is sort of like probably 80-90% of our customers will use in conjunction with the castable urethanes that eventually become the parts. So you've got you'll hear a term called tin-based silicone and platinum-based. Those are not necessarily, it's not like having a gold card versus a platinum card. It actually has to do with the catalyst. It's actually one uses tin, one uses platinum. The tin silicones are very user-friendly. Taxidermists use them. I mean, you could literally take a frozen fish and pour a tin silicone on it, pop it out, and now you can make fake fish that look like the real thing. They'll cure on almost anything. The downside is there are some of the castable materials that don't like to cure in a tin silicone. It's some of our we've got some water clear materials that are really neat, like optically clear materials. They don't really like the tin silicones, and then we've got some of our softer, lower durometer urethanes that don't like to cure in them. And that's where, honestly, you just call us and we can walk you through it. But just in a nutshell, that's sort of it. The downside with tins as well is BJB doesn't really offer quite as wide of a variety of durometers. So the most common one we have is about a 25 Shore A, which is it's bendy. If you've got some undercuts and whatnot, it works pretty good. But sometimes we'll get the parts like this, where if you need things to be very dimensionally accurate, and if that mold moves just a little bit, it kind of can throw apart mating parts. The platinum silicones, we have a much broader range. And the platinums tend to be what we consider a little bit more long-term good production molds. They tend to be more dimensionally stable. They handle a little bit of heat better. And then if you go and put it on the shelf 2 years from now, you come back, they should be the same size. Tin silicones don't always have the right library life. But having said that, each kind of have their own sort of place. There's some clays that sculptors will use. They don't want to get anywhere near the platinum silicones because they won't like the sulfur in the clay. So It is a kind of a weird thing. You have to kind of walk a line. We've got a lot of information on that in our product guide. We've got like a little kind of almost like a cheat sheet guide for that. But yeah, a lot of times you just call us and we'll talk. So that's sort of silicones.
Cool.
And that's sort of the simplified version of it. Now, when it comes to casting materials, with our products, we don't have just sort of rigid and flexible materials. We sort of have everything from almost skin-like materials all the way up to very rigid, almost polycarbonate-like that mimic a lot of injection molded plastics. So really, you just kind of have to pick the part. What does the part need to do? If you need a rubber, the most common durometer hardness that we use is a 60 Shore A. That is basically like an automobile tire. That's a 60 Shore A. A pencil eraser is a little bit softer, like a 40, and then like a skateboard wheel, like a good, nice longboard wheel, like an 80, 85 Shore A, and then a kind of every iteration from there. So a lot of our parts, obviously, a lot of people are making rigid parts, kind of ABS-like, with that nice rigidity, not too brittle, not too flexible and whatnot. It's kind of we have a lot of different systems, and so yeah,
cool.
I wish it was just a simplified thing, but then again, it kind of gives us job security because if you think one material will do it all, it's kind of like PLA versus ABS, and then you start getting these little blends of things. You can have one material that does a lot, and kind of but then sometimes these applications are getting more and more specific these days. Everything's very engineered, and everybody wants something a little bit different, so we cover a really broad spectrum.
When I've been a BJB customer for think 12 years now. And one of the coolest things is you call and then you say, hey, I've got this specific application, and someone on the other end of the phone magically says you should get this, and it's worked every time. It's pretty amazing, the customer service. So
Sweet.
kind of the same thing with Matterhackers and 3D printing. It's a good go-to source.
And even if we aren't comfortable saying this is the product, we've got the cured samples. They'll say, I'm going to mail you this. You touch them, squeeze them, drill them, hit them with a hammer, do whatever you got to do, and then come back and say which one did you like the most.
Yeah.
And then, no UPS, no gallon kit at the other end with material that you're not going to be able to use. And so, so that's very helpful.
Great.
But yeah, it's a fun industry. And so, from our standpoint, we're very, very in tune with what's going on now with this type of stuff. 3D printing, how it affects us, and then we've obviously, we try to do as good of a job as we can marketing to that audience. And it's kind of funny. I know I've been sending you some pictures of. I've been working on a project. This was my show and tell for the day. But basically, here in California, we've got like 21 missions, and at 4th grade, all the kids have to do this study mission project.
Yep.
And I always joke because I always thought, even as a kid, it was always the chance for the dads to show off like whatever. And of course, when I was a kid, I didn't do a good job. I told my dad last minute the night before, and we glued our sugar cubes together
Cobbled
and
something together.
Yeah, cardboard, and it was terrible. And I said, I'm not going to do that to my daughter. So I asked my daughter, I said, what do you want to do? How do we want to do this? I said, hey, how about we 3D print one? And I got on the Google, started looking around, and I went, wow, this has not really been done. I think I found one person who did it. And so there were no missions, so we sat down in Tinkercad, and I started exposing her to design, simple design. And what do you want to do? How do you want to approach this? And she was very integral in the design process. The decisions we made, and then printing it. I have a printer at home, and then I have one here at work that sits around doing nothing a lot. So we ended up doing this. So this was the this is the mission. In Orange County, there's San Juan Capistrano, which everybody wants to do because you can run down there and get your whole project. They forbid this class to do it, so we had to do all these other ones. So this one is the San Gabriel Archangel, which is up in, technically it's kind of like an eastern part of LA County. So this is kind of the starting of it. But yeah, this is your guys' PLA.
Yeah.
The bells are PETG with a little spray paint on them, and yeah, she's been having a blast. And then my daughter will be going in and adding the color. We'll get this obviously mounted on a board.
Cool.
And then this, the roof material is called lay brick.
Yep.
Right? So it's kind of a unique, kind of a sandstone feel. We stained it. That was kind of cool. We just took some regular old stain.
Yeah, it
and
works.
yeah, it's going to give it a really nice, kind of a cool rustic feel. Just
Yeah.
yeah. So we're going to be finishing that. So I thought I could easily run down to one of these hobby stores or even online for $15. You can buy laser cut kits, and I thought, well, how is that any real different than Dad showing how to 3D print it?
Use the technology that you have in front of you. Yeah, it's
I
great.
guarantee there's not going to be another one of those in class. So, and I'll put those files up on Thingiverse to help out some other dads out there if you need it, because there's not a whole lot of stuff out there. I guarantee
Get
that.
that start.
Yeah. So I thought, but if I go into show kids, this is the ripe age, 4th graders, 5th graders, 6th graders, if they haven't already been exposed to it, they're going to shortly.
Yeah.
And I think this is a neat thing to show.
I think it's a great story of the utility of 3D printing, because people come up to us at shows, they come into our showroom, hey, why do I need a 3D printer? It's either how do I make money on the 3D printer, or why do I need a 3D printer?
Yeah.
And the answer to why do I need a 3D printer is I can never have that conversation with any specific human, because everybody has essentially a different pair of goggles that they see life through. So I'm a mechanical engineer, so I love functional prototypes and spinning parts and the thing, the print in place gears that kind of spin right when they pull off the bed. I love those types of things. Alec loves cosplay and the video games, so he's going to do those things. You bought your printer for some specific thing, but you could have never told your future self that you were going to 3D print a mission for your daughter later. So it's like this organic thing that happens.
Yeah.
Why do you need a 3D printer? I don't know. Get one and you'll kind of figure it out after a year if you're still using it. So it's really this cool story of everybody looks at the world differently, and whatever utility you need to fill. I'm like fixing windows that are leaky back at home by making these little parts and silicone them on. So
Yeah, I made
It's
a
just funny.
download. I went looking one day on Thingiverse, and I was tired of my flag that's outside of my house. I was tired of it getting wrapped up, and I was just kind of like, well, I'm too cheap to go out and buy the heavy duty $80 set, whatever
Yeah.
that comes with the bearings and everything. Somebody had the file up there to do those
Yeah.
bearings, and it was adapted to the right size pole, and now
Magic.
my flag is always magically unfurled,
Yeah.
and I really thought that was kind of cool. And it's fun because my neighbors, I'm like, come here, check this
Yeah.
out, and
Yeah.
I'm an evangelist of 3D printing. I show everybody possible. When people come over to my house, I go, come on out in the garage, you got to see this.
Yep.
And if you're in business, if you're in manufacturing, you got to know about this, because this is a paradigm shift. This
Yep.
is, what's coming, and the sooner you get on board, the sooner you're aware of it, the sooner you'll know whether you can use that to your advantage. It's just another tool. 20 years ago, CNC machines were very unique and very expensive. Now, I mean, we've got 2 of them in the back. We make buckets of goo. What do we need CNC machines for? Well, we use it because we use it for our equipment.
Yeah.
We make all sorts of little parts for it for, a variety of things. Okay, so same thing. We use our 3D printer to educate our customers.
Yep.
Hey, you got a 3D printer? This is how it works for us. And so, yeah, I mean, get on board. There's no reason not to. It's a cool thing.
The other fun answer is like, I don't know, what would you do? What do you make with a table saw? That answer is also like this limitless thing. That's
Yeah.
kind of synonymous to what you're saying, and CNC machines for making goop. They're
Yeah.
not related, but related all at
Yeah.
the same time. You gotta keep an open mind.
And it's fairly clean, I mean, if you're in a garage setting, I mean, it doesn't really take up a whole lot of space, and you can just press go and just keep it, you just keep an eye on it, you keep checking on it, make sure nothing happens. Really, most of the time, most of my stuff's reliable enough. I just come back and the parts are done.
Yeah.
But sometimes you got to stop it and say, okay, I don't like the way this is looking. I'll go in, change the infill, change the support, and then
It all has to do a lot with the first layer. So if you watch the first 3 minutes of the first layer go down, if that's looking good, you can pretty much walk away, and 99%
Yeah.
of the time it
Yeah.
ends up good. So
Yeah.
the paying attention and the kind of tuning in is really optimized on that first layer.
Cool.
And there's some cool features in Matter Control that let you allow to kind of actively tune that in as well.
So like if your bed is like disc shaped, it can compensate for that and print around that and still have the first layer be flat and adhere to that.
Wow.
So it's got a wizard that walks you through the steps to make sure that your bed is as level as it can be for the software to program around.
Yeah.
It's all part of that like out-of-box experience, succeed on the first time experience that the whole industry is focused on. That
Yeah.
can happen.
Yeah, we've got we had upgraded to the new Axiom, which it is a step above. It's more of like a semi-professional type,
Yep.
because of the price range.
Yeah.
But what's really neat about it is it's got like the self-leveling. It's almost
Yeah.
got like it touches all 4 corners where you don't have to come in and manually do it. But whereas my printer at home, once I dial it in, I really don't have to touch it.
Yeah.
Unless I move it or knock it, something happens, whatever. But most of the time it's fine. But it's kind of nice to not have to deal with that, because in previous printers way in the past, sometimes from heat, temperature differences, things move around on you, and if you don't get that first layer done right, then yeah, kind of the rest of the print can
Yeah, and
be
the
a
difference in
crapshoot.
spending, $800 on a machine and $2,000 on a machine is a
Yeah.
lot of that, self-leveling features and things like that.
Yeah, that's cool. So what's exciting for you guys kind of coming up? Is it all these new materials? I mean, we're popping out all these, carbon filled, and then there's even like some of the filament, like the continuous filament stuff is really fascinating to me. Being kind of more an ex kind of composites guy, I was really interested in that. Plus you've got the metal filled stuff, and then there's a whole nother world of even like the biomedical stuff, which is
Yep.
just fascinating. But in your guys' world, like what do you see as kind of like the up and coming sort of stuff?
So PLA has always been kind of the roots of the industry. That as a material it's the easiest. It's what most people print with. But the ability to kind of see that shifting more towards PETGs and things like that is really, I think, really exciting. And there are different pillars within the advancing of 3D printing technology. There's the software, which is kind of how am I going to interact with this machine. There's the mechatronics, which have been patented since the early 80s. Those haven't changed much. And it's tougher to get faster, to 3D print much faster at this point in time with the materials that we have, because you can only extrude them at such a rate, right?
Yeah.
So then it comes into materials. And the materials, I think, is that key, where if we can find materials that extrude faster, the mechatronics can certainly keep up with it. The software can be tuned to the whole system, and that's how the packages work together. So If we can find materials that print faster and materials that are, the reason you're hearing about more materials is because someone's coming up with something that suits their needs. We have, you know, a brick material here, we have a wood-filled material here, we have the iron magnetic material there. Those are all specific. Somebody needed them, so somebody created them.
Yeah.
So companies like Protopasta out of Seattle are doing great work.
That's cool.
There's just a lot of really cool things going on in the materials development. And I think they'll be very focused to certain customers, but someday it'll be like, oh, I need that, and it'll be available. So
Yeah, that's really neat.
we're always trying to onboard new and exciting materials to offer to our customers.
And you know, it was a learning curve even with using this stuff. I mean, the feed rates, I had to slow down almost half
Yep.
speed from what I was printing PLA at, you know, at a certain thickness and stuff. And so it's a learning curve. So it's because even when new materials come out, you've got to learn how to work with them. I
Yep.
mean, you've got to kind of learn the nuances and whatnot. It's just like printing with nylon or polycarbonate. There's a steep learning curve if you just jump into it. And you're like, okay, now I need to figure out how to get it to stay stuck to the bed,
Yep.
and a lot of those things, and feed rates and temperatures and stuff. So yeah, it's kind of a but you know, as someone who enjoys the tinkering, doesn't bother me. But there are a lot of people out there who just say, you know what, I just want to press the button and go. I don't have time to do that. And as much as I like to tinker, I don't technically have the time to do that. You know, I'm busy. I've got, you know, dogs, kids, you know, schedule, business, family, you know, and the whole thing. And it's like, I do like to go out and just push button, go,
Yep.
and then check on it every 10 or 15 minutes. And okay, I come back and not have to sit there and manually
Yep.
tinker with things. So that's kind of cool.
Dave, I have a question coming in.
Yeah.
Okay.
Is there a carvable filament once you print something?
So everything is modifiable, right? So Alex talking about printing with PLA, and you can sand it. PLA kind of is not that fun to sand because it's really tough at room temperature. In terms of like carving something, or maybe let's say you print out a square piece of material and you want to put wood grain in or something, a Dremel or something like that actually goes a long way. So it takes some elbow grease, but at the same time you get a lot out of a little bit of work into it.
What about like this wood-filled stuff? Because this actually looks like
Yeah.
pretty. Does this stuff sand pretty good?
It sands and it actually stains, kind of like you did with that one. It's kind of when it's printing, it sort of smells like pine trees.
Oh.
Only when it's printing, not afterwards.
I
so
know.
much,
Well, we can
yeah.
put a little Lysol
Yeah.
or something on there. You
absolutely.
know, pine salt.
So all the materials are fairly modifiable. It's kind of like how you want to do it. So ABS is one that might take to a Dremel real well, and then you can sand it and polish it after that.
Oh, and I think I saw somewhere, and not necessarily from your camp, but I saw a filament out there that I think was almost like clay, and then people could come in like with either like water or something like that, and then continue to smooth it. So I'm sure there's like little things like that are coming on. I have talking about like how things advance quickly. You know, a couple years ago, I've mentioned it several times on this show. I mentioned it. I've always been an RC guy. I've done a lot of stuff over the years with RC airplanes and whatnot, and I never thought we'd be at the point now where people were printing successfully lightweight, strong enough, look good, flyable RC airplanes. Now the quadcopter is different because you got four motors. You've got your power to weight is totally different. You can make a brick fly, but with an airplane, you got to keep it light, structurally rigid, and everything. And there's a company out of a group of guys, I should say, out of the Czech Republic called 3D Lab Print. And I've printed a couple of their airplanes, and it's phenomenal. In fact, I just flew my first fully 3D printed airplane, and I mean, like, it's hard to blow my mind after getting to work with all these kind of materials and 3D printing. And I thought, oh my gosh, it's happening. It is happening. And then I have another. I 3D printed a fairly good size, World War II Spitfire. There's a Spitfire, there's a Mustang, there's a German Messerschmitt. I did the Spitfire. I haven't even flown it. I printed it about a year ago, and I just kind of so busy. I ended up printing another one, and I was just like, I have no fear now flying my Spitfire. So it's just, if you'd asked me 2 years ago if that was going to be possible, I'd be like, well, I've seen some designs. They were kind of clunky, but people figured out how to design it for the material process, and they figured it out, and it's brilliant. And now they're printing stuff that is really large scale. like these Stearman biplanes with all the radial engine details, and it's fantastic. And
Yeah.
I can't imagine 2 or 3 years from now what that type of stuff's going to look like. So
There's
it's
even
fun.
some open source projects. If you look up like OpenRC, and they make a like fully 3D printable race cars, and it's not like, oh, and then you put on the rubber wheels. You're 3D printing the wheels out of flexible materials.
Yeah.
All the transaxles, all the springs and shocks are all happening using 3D printing. And there's like one guy, Daniel, that's leading that group, but it's an open source project.
Yeah.
So, tinkerers with free time in the afternoon can contribute back to that project, make it more printable, make it run better, make the car faster, anything like that. It's similar to maybe like the Enable project, where we make you can 3D print prosthetic hands.
Oh,
Also,
man, that's like a
open
whole nother-
source. Yeah.
That's incredible, and that's using 3D printing for helping people who we can all agree it's a fantastic thing, and people are dedicating open time on their printers and then donating these parts because they want to do something, want to pay it forward, and that's what I love about the internet is a funny thing. You can go there for cat videos and to spew nasty comments all over the place. But those of us who would like to be productive and want to help and share, the information's there.
Yeah.
I mean, you can go on YouTube, and I'll throw in they've got a nice YouTube channel with all their videos as well. But if you go to the internet and you look for good, there's a lot of bad information, but you'll find those gems that will just go, oh, finally, I figured out how to do it. I mean, anything from fixing your car or whatever. But even if you feel intimidated into jumping into something like this, the cool thing is there's a YouTube video, or there's a blog about it, or there's a chat discussion room, which I know you guys have.
Yep.
And it's like the stuff's out there, and people genuinely want to help. They're excited because they understand that if you participate and you give into this, you'll be able to get stuff out. And so everybody's this open source thing. I mean, I look at Thingiverse, and I can't imagine, for the few years that I've been watching that and watching it grow, it's incredible to see what you can just go on and just download, and people are excited. I've got a couple designs up there, little things I've tweaked and modified, and it's almost like you get this fun little giddy feeling that someone downloaded my file.
And a version of it.
And that's times, hundreds of thousands of people now out there, and everybody kind of has that.
Well, it's a part repository that's, I think it's 6 or 7 years old at this point. So nothing ever goes away. It just keeps piling. You now, after in a couple weeks, people will find some mission on there. Like, thank goodness, someone did my work for me.
Yeah. Or at least something to use and then modify and kind of.
Yeah.
But I mean, this is going to happen. I was having a conversation with someone. It's like, can you imagine parts replacement for things like my wife asked me to make her a dishwasher wheel replacement thing for something out of work, and I said, you know what, I'm just going to draft that up, and I did it in Tinkercad, and I stuck the file up there, and it's been downloaded. I don't know how many times now. And it's little things like that. Even large-scale manufacturers are going to probably come to the point where they're going to say, I'm just going to put a file up there. You can go to McMaster and download STL files.
Yep, absolutely.
And that's the future. That's what's coming. And some people know about it, and some people are using that already. But there's a lot of other people, and I think even businesses need to be aware that that's what's going to happen. And the sooner you jump on board and find out how to use that to your advantage, the better off you are.
And I think that's, we're right on this cliff where that's about to happen, and probably in the next 2 to 3 years. I think the only thing preventing, let's say, Black & Decker or even Disney from releasing all their digital designs and digital files is the DRM, the digital rights management, which is kind of a corporate jargon of figuring out how to make sure they aren't used for an incorrect purpose, or
the
how are
IP
you
is
paying for these certain things. So something that I think the industry is going to be working on moving forward with.
Yeah, right now it's almost like Napster, and then soon it'll become more like iTunes. So it'll be, because for some of these projects, for example, the RC design that you download the whole file set for like $20. Well, someone who can appreciate how much time and effort it would take for me to build that from scratch, or even
Worth
from
way
a
more
kit,
than $20.
$20 is nothing for the quality of the file. So if I had to download a dishwasher wheel, and I could order on Amazon, which is fine, or if I have my 3D printer, it's 3D printable. If I 50 cents to $1 or something like that, kind of like
Just
buying
go.
an iTunes file, it's totally worth it. So.
I actually the other day saw at Staples that Robo has a flash drive that you can buy that's got like kitchen utensils or like different things, just like 20 different files for around the house that you can just
Yep.
print.
That's cool.
Just go in the store and buy a file. That's it.
Yeah, some of those are embedded in Matter Control as well.
Yeah.
Awesome. Well, cool. Well, this is kind of one of those things where we could stand here and talk about this all day. I mean, it's just,
Oh, yeah.
this is really neat stuff, and that's why I was so excited to get you guys in here,
Yeah.
because it's like, once again, you don't know what you're going to do with a 3D printer, but and also when you get a couple of guys that know how all this stuff works, you never know what's going to come out from an information standpoint and the value of the information that's coming along. So the sooner you tune in, the better. And I've always really appreciated your guys' help with finding the materials. I have complete respect for the way you filter through, like, even the hardware. You guys test it, what works, and then you can help people with that. Because if you're left to just going and finding it on your own, learning through tribal knowledge of the randomness of the internet, you might get steered down certain rabbit holes. So there's a lot of value in having a place you can go. Number one, the filament's good. Number two, the products that they sell and they stand behind them. And then just not even talking about the software. I mean, all that stuff is very complicated and a nice package. So I appreciate it. So we're always excited to find a reason to. You guys are like practically on my way home, so it's fun. I go in on a Friday and I'm like, okay, kids, let's go. Let's
Hang
get
out
some
for a couple
filament.
hours,
And I know you guys are. You need to have more of like a hangout space in there, because
Yeah.
I would hang out there a lot more. But no, I really appreciate you guys coming in. And Haley's up there at the switchboard. Are there any more questions on stuff?
No, I think we're about
Cool.
ready.
Cool.
Well, thanks for having us. Hopefully this is the
Yeah.
first trip of a
Yeah.
couple, and we can kind of.
Thanks so much. Yeah. And likewise, when you're getting to a point where you need some molding, you can kind of look. They can't see it, but if you look around this room, and we've got so much stuff and going on, and there's so many cool techniques. We deal with so many cool people. I mean, just the basic manufacturing end of it, which is our core structure of our business. We just everyday mundane type of things, but it keeps the world and our economy and everything kind of going along. But then we get exposed to a lot of really fun stuff, the movie special effects, cosplay, artist type things, and in the kind of the fun visual stuff that is a nice break from a rubber grommet or an engine mount or something like that. But we've got a lot of talent in our tech department who are widely sort of skilled in a variety of things. And so, like, setting up parting lines, how do I approach this? If I want to cast this part, where do I put the fill port, the vents, and stuff like that. So it's cool. So you can always use us for that type of help. But
We'll do that.
Cool. Yeah.
Yeah.
Awesome. So if you guys have any questions along the way, be sure to put them in the comments below. And questions about materials, you can obviously contact us. Make sure you go check out Matterhackers' website. They've got a lot of cool stuff up there, more content coming. And other than that, thanks a lot, guys, for coming.
Sounds good. We'll
Thanks
be
for having
back.
us.
All right.